You may be one of those people that's obsessed with maximizing your muscle gains, and one question that pops up from time to time is the effect that alcohol has on muscle growth after exercise. Well, in this content, we'll be going into the science to answer that question in detail, so stay tuned.
Learn Your Body, a science-based education.
The information I'll be going over stems from a study that I will have linked for you along with my notes and any following amendments that may need to be made. That said, the researchers of the study aimed to find how drinking alcohol impacted muscle synthesis, or the creation of more muscle. They probed the question by recruiting 8 young individuals that were placed in 3 conditions. The first condition was the consumption of protein only. The second condition was a carbohydrate plus alcohol consumption, and the third was protein and alcohol consumption. Participants, when in the protein condition, consumed 25 grams of whey protein immediately after exercise, or equal amount of carbohydrate if in the carbohydrate group, then again 4 hours later. They then consumed 6 alcoholic drinks starting 1 hour after exercise and spread out over 3 hours. The alcohol, if you care, was vodka and orange juice, commonly called a screwdriver. For the protein-only condition, they consumed orange juice without the addition of vodka. Too bad. Participants were instructed to finish their drink within 5 minutes, so no sipping, down that drink. Clearly, this would likely lead to intoxication, commonly called getting hammered, drunk, inebriated, lit, litty, and the classic up. The exercise performed was extremely basic, just a leg extension for 8 sets of 5 repetitions at a somewhat difficult weight, around 80% of their 1 repetition maximum. And now onto the data. First, the researchers checked the blood alcohol and amino acid or protein levels in the bloodstream after consumption of each to determine if the consumption worked. You might wonder why they do this, because of course it would work, but it's good scientific rigor to check. I won't show the data on the screen because, well, it doesn't add much, but the answer is yes, they got drunk. And those that consume protein had elevated amino acids. Great. Proof that the treatments worked. Next, they looked at particular molecules that are heavily implicated in muscle growth: mTOR and EEF2. mTOR is a master molecule that controls protein synthesis, or the production of more protein for the building of more muscle. If it is elevated, you can imagine it's likely that protein synthesis is elevated, although not conclusive proof. On the other hand, just because protein synthesis begins does not mean it will be continued, and here is where EEF, known as eukaryotic elongation factor, plays its role. When phosphorylated or tagged, EEF inhibits protein synthesis from continuing, so the less phosphorylated EEF there is, the more protein synthesis can occur. Again, not definitive proof, but a good extra measure along with mTOR. So, to be clear, the more mTOR and the less phospho-EEF, the more protein synthesis in general. So, the researchers took muscle biopsies, meaning they took pieces of muscle from the participants of the study at various time points, at rest or before exercise, then again under each condition, with and without alcohol, at the 2-hour mark and the 8-hour mark post-exercise. mTOR levels are highly elevated at the 2-hour mark in the protein-only condition. No shock there. There was also an increase in almost all other conditions, including carbohydrate and alcohol conditions. However, the increase in mTOR activation was dampened when compared to protein alone. I'll explain that in just a minute. First, let's look at phosphorylated EEF. Phospho-EEF was reduced in all conditions except the 8-hour protein condition compared to the resting, non-exercise condition. However, there were no differences between the conditions otherwise. This means that alcohol and carbohydrates, but we're interested in alcohol, reduces the activation of mTOR, but has no negative effect on phospho-EEF. However, if we take things one step further and investigate overall total protein that is actually, synthesized, not just the molecules involved, there is an increase in protein synthesis in the protein condition, and, as might be expected, a reduction when alcohol was later consumed. This confirms that alcohol reduces protein synthesis in the muscle after exercise. So, although I didn't cover all the data, which I encourage that you do for yourself, it does seem that alcohol in pretty heavy amounts decreases protein synthesis, and this could translate to decreased muscle mass, although those direct measures were not made, because the study was only a single time point. I hope this proved informative for you, and if you'd like to learn more on the topic, certainly keep diving more into it. I hope to have the pleasure of speaking with you there. Cheers.